In this video, we'll cover the material, the content, and give some examples from section 10.8, which is about the complex numbers. So our objectives are to understand the imaginary and complex numbers and the subtle difference between the two. To understand how to do addition and subtraction of complex numbers. To understand how to do multiplication of complex numbers. To define a conjugate of a complex number and use that conjugate to do division of complex numbers. So imaginary and complex numbers are all about the fact that negative numbers don't have square roots when we're talking about real numbers. Remember, I've said this over and over, well, we're in the real number world, so no, we cannot take the square root of a negative number. But we have a larger number system that encompasses the real numbers, but also includes the negative number square roots. And we call that the complex number system. And that number system makes use of another number that we're introducing. And that number is represented by the letter I. And by definition, it's the square root of -1. So I is the unique number that is the square root of -1. And I squared is -1. So now we can do any negative number. Like we could do the square root of, I don't know, we could do the square root of 7 by saying that's equal to the square root of we could do the square root of -7 by saying that's the square root of -1 times the square root of 7, which would give us I times the square root of 7. Any number, any negative number now has a square root in the complex number system. So what will be the square root of -9? Well, I always write these out, so I have the square root of -1 times the square root of 9. And then this is I, and this is 3, which we will always then write like this, 3I. And this one, we have the opposite of the square root of -1 times the square root of 48. And we can further break down the square root of 48 into what? The square root of 16 times the square root of 3. Okay? And since I know, and I'll keep the -1 here and negative. Now, since I know that I'm going to put my number first, I'm going to take this square root first. So it'll be -4I times the square root of 3. So an imaginary number is a number which can be written in the form a plus bi, where b is not 0. In other words, there is a component of the number that has that I in it. Okay, that's why b can't be 0. A could be 0. So 3I is an imaginary number. 4 plus 3I is an imaginary number. And if we put together those imaginary numbers with the real numbers, we come up with this set called the complex numbers. And a complex number definition looks a heck of a lot like the imaginary number definition. And here's the difference. B can now be 0. So it includes all the ones without that I component and all the ones with it. But important distinction. So here's kind of a chart that I would pause the video here and kind of check this out and look at how the hierarchy of things and how things go together to come up with the complex numbers. So the complex numbers do obey the commutative, associative, and distributive laws. So we can add them and subtract them just as we do binomials. They're binomials because they have two terms. So we can do the same way. So we can do, in this one, this is a plus. So we can do 3 plus 7 equals 10. I should put this down here. 10 plus 2i plus 8i equals 10i. And over here, this is a minus, so I'm going to rewrite this as 10 minus 2i minus 9 minus I. 10 minus 9 is 1. Negative 2i minus another I is minus 3i. So addition and subtraction follows all the same rules. Almost think of it as I is a variable. If you think of it that way, you can see how it looks exactly the same. Now, it is not a variable, but it's treated in the same way as a variable is when we're combining like terms. And that's why I say to think of that, think back to when you were doing it with variables. To multiply, we're going to first put each radical in terms of I. So you see here that they pulled out the square root of negative 1. They pulled out the square root of negative 1. And they made each of those I. Which gives you I squared, which is negative 1. So we have negative square root of 30. Now let me point out something extremely important at this point. If you had just multiplied the radicands at this point, you wouldn't end up with that very important negative, because you would have multiplied negative by negative and gotten positive and taken the square root of positive 30. And that's not what we're doing. So when you are simplifying radicals that have negative even roots, you have to take the i's out first. So this one we have I times the square root of 2 times I times the square root of 10. And what does that give us? I squared, which is negative 1, square root of 20. 20 has a 4 in it. Square root of 4 is 2, so it's negative 2 square roots of 5. Here we're going to have to distribute. So we'll do 2i times 5 is 10i, plus 2 times 3 is 6. I squared is negative 1, so it's negative 6. So you have 10i minus 6. And here you're going to have to FOIL. First times first is 8. Outers is negative 6i. Inners is plus 4i, and I'm going to write them on top of each other like that so it's easy to add them up. And then last is minus 3 times minus 1, which is plus 3. I could have written that over here underneath the 8. 8 plus 3 is 11. To be consistent, I could have done that. Minus 2i. Okay, what about this conjugate? Conjugate is the exact same thing as what we were doing before with radicals. The conjugate of a complex number, you change the sign in the middle. Only the sign in the middle, just change it. If it's plus, make it minus. If it's minus, make it plus. The whole reason for that, remember, is to have the outers and inners fall out. So and in this case, the outers and inners would be the ones with the i's in them. So the complex part falls out. The imaginary component is gone. And we can use that to divide complex numbers. And basically, we're not dividing, we don't have a division algorithm. We're doing the same thing as what we did when we rationalized the denominator to clear out the I. Let me show you what it looks like, okay? This, what's A? A is 0. What's 1? What's B? 1. So the conjugate of I is what? Well, you could just use I, or you could use negative I. I'm just going to use negative I because I want to keep the conjugates, I want to keep this consistent. So this was originally 0 plus 1i. So I'm going to multiply by 0 minus 1i over minus 1i. And excuse me, I'm working across because I have another one stuck underneath me, which is not fun. So actually I'm going to scratch this out and put it up here. 4 plus I over 2 minus 3i, and that lets me keep working down, which is important to me. So 3 times negative I is negative 3i, plus 2 times negative I. Well, I times I is I squared, which is negative 1. So the negatives cancel each other out, and I'm left with plus 2 over I times negative I squared is negative 1. The negatives cancel each other out, and I get a 1. So my answer, because anything divided by 1 is itself, is negative 3i plus 2. Over here, my conjugate, I'm going to do it in another color, is 2 plus 3i over 2 plus 3i. Remember, whatever I do to the top, I have to do to the bottom. There's no equal sign that lets me do anything like multiply each side by something other than 1. The only thing I can multiply when I don't have an equal sign is 1. Okay, so on the top, we're going to FOIL it, and we're going to get 8 plus 12i plus 2i minus 3, and on the bottom, we're going to get 4 plus 3. Remember, outers and inners drop out. That's why we make that conjugate. I'm sorry, plus 9. 3 times 3 is 9. I times I is I squared, which is negative 1. The negatives cancel each other out, and we have plus 9. So now I'll combine things on the top, and I will get 8 minus 3 is 5 plus 14i over 13. Okay, so powers of I. It's easy to simplify powers of I. Express things in terms of I squared, and if you have an I left over from an odd exponent, you keep the I in there, and then we just go ahead and figure out whether we have even or odd. Okay? Looks like this. I to the 40th power. Okay? So that's I squared to the 20th power, which is negative 1 to the 20th power. An odd number to an even power gives you a positive. Not an odd number to an even power, a negative number to an even power gives you positive. So we're going to get positive 1. Here we have I squared to the 16th power, because the closest thing we have to an even number is 32, but we have another I left over. Well, I squared is negative 1 to the 16th power times I. I'm going to say it right this time. A negative number taken to an even power gives you a positive number. So we have positive 1I, or just I.